Okay, so now let's talk about Terragrant. So what is Terragrant? Why to use it? Why not to use it? Maybe I will tell very small subset of information which I can tell, or which I want to tell. This is primarily because of time limitations, not because I want to hide something. So if I will understand that we are very much out of time, I will just cut there and make the rest for next time. Honestly, I didn't expect to spend so much for Terragrant, but when I was preparing for this, I discovered a lot of things. Okay, so Terragrant. Terragrant is a tool created by GrantWorks, I think in about 2015, or maybe end of 15, 16, I don't remember. This kind of tool is initially created to fill missing gaps of Terraform. Okay, if you remember, or if you think that this is all what it can do, or when you looked at this tool before and you think that nothing has changed, you are absolutely wrong. This tool has evolved significantly, and well, I have cold coffee. Good, cold coffee is still good. And this tool has evolved so much, and it has been developing in so different directions that it's really hard to highlight. Just forget everything what you knew about it if you've been using it before. Okay, you are totally new. So the first thing here is that Terragrant is project by GrantWorks, is completely open source, and it has started as a tool to add missing bits to Terraform, like state locking using DynamoDB, and something else what I even forgot right now because it was so long time ago. Anyway, Terragrant is doing a large amount of things which you, as in analogy with CloudFormation and CDK, would be thinking about, hey, why CloudFormation is so bad, or why I have to use this, and why it feels so unnatural. The same thing goes with using tools like Terraform. You start using it, you are writing 1 file, 2 files, 100 files, and then you think like, now it sounds a little bit too hard, or I have no clue what's going on. And you will natively evolve into something like Makefile to orchestrate your invocations or some code generations, because you feel that you are repeating yourself way too much. So for me, that's exactly where Terragrant is right now. Everything what you have been struggling with Terraform potentially can be solved using Terragrant. Potentially is keyword here. Okay, let's look into a website. Terragrant.grantwork.io is a website where we have documentation. Documentation is not as bad as you may think, because I increased font size. Honestly, the worst part in this website is small font size. Well, I have to increase it every time. No, I don't know why I'm joking so much today. It's serious stuff, you know, guys. So, first thing here is why it is needed. Okay, few people wonder, why do we need to use something like any other tools if we're happy with Terraform? Well, you are happy with Terraform. I'm just going to look into feature sections and talk about some of this in more details. When you're working, and I will show much more code later, but I just want to start with what is it. Okay, if I show you 2 pieces of code, it may be not as impressive as about highlighting what are actually the features of it. So Terragrant allows us to focus on what is actually the essential part of your infrastructure. And every time when I'm thinking about what is infrastructure, I'm thinking about just calling some libraries, calling some module, calling some reusable component, and tell what I want it to do. that's pretty much it. I don't want to care about what is actually inside and what kind of limitations Terraform has and so on. As a user, that's my entry point. I don't want to do anything else than just providing values into my modules, and then infrastructure is created and I can happily use it. I don't care if even Pulumi is used inside of it. Honestly, that's not what I'm worried about. So I really want to focus on dryness, because I don't want to repeat my configurations more necessary or more often than it is necessary. And for me, dryness is removing everything what is not everything what is repeated into fewer places. So using some sort of code compositions or using some sort of like variety of different patterns by reducing amount of files and amount of places where I have to go and apply changes. You may disagree that dry is this, and I'm not going to argue, because dry is a little bit dry is not dry, honestly. So another thing is that it allows you to keep configuration of remote state in very canonical way in very few places. Literally in one place per project is good practice. And then you can also tell how to actually invoke Terraform with what kind of parameters you want to invoke it, and so on. I will go through this in much more details. And additionally, it allows you to work with multiple entities. By default, it's focusing on AWS accounts, but I don't think there are any like technical limitations let's say to work with multiple Azure subscription. If you want, you can do this quite successfully with Azure subscription, no problems. So when we are looking into multiple resources, that's where code reusability is essential. You don't want to copy paste something for many environments or many AWS accounts. You want to parameterize your AWS account. And Terragrant has ways and has functions which you can use to, let's say, get account ID. Another cool thing is possibility of running different hooks before and after. So you may know different, you may understand sequence of different commands, how it runs. So for example, when we are working with Terraform, we run init, plan, apply, and that's it. When we are invoking some tool like Terragrant, it injects its own hooks between calling Terraform. So we can say before apply, do this, or after plan, do that, and so on. Again, I will show much more that. Auto retry, well, it's good, but I don't really understand how it works in details, because sometimes there can be different types of auto retries. Like what can be the problem? The problem with Terraform is fine, but the problem with providers downstream is another type of retries. What Terragrant is able to help you with is that if registry suddenly is unavailable, or if GitHub is suddenly unavailable and it cannot pull your source code, for example, then it will try to retry it again. Caching is another interesting piece which was added, or which was like improved quite recently. It took several iterations to make it actually useful, as far as I understand, because there were some strange like downsides when this was integrated during last month or so, and so on. AWS house means that Terragrant is able to do a little bit more. So before it's doing something, it can assume some IAM roles, and it can understand how to use different profiles and so on. Debugging, well, this is big question mark. The thing is that debugging in Terraform is challenged. Debugging in Terragrant is also challenging because it doesn't give you enough context. It gives you some information about which variables were passed here and there, but not so helpful, let's say, from end user perspective. And you will still see a lot of error messages when you use it, which will simply say some encrypted message which you hardly understand who is generating it and why. Okay, so this was pretty much features as they announce it and as it is described on their website. Now let's go through. So there were a couple of questions which people asked already. Let me just see a few questions here. I will just put them on screen for now, but I'm not going to answer them probably immediately. So yeah, the first question: how do you handle inheritance with Terragrant? What would be the best practice? And I will just move a little bit to the side so that you can see here. I am using the read Terragrant config, but I'm not sure if it's the right thing to do. Well, usually there is no right thing to do. If you are unsure that this is the right way to do or not right, ask someone else to look at this and let them to explain what's going on. If they will look at this and think like, I don't understand what's going on here, then you did something wrong. And this is typically what I see with project where developers who created this understand it very well, but users or even these developers after some break doesn't understand what's going on, why he did this way, and so on. So just look another peer or ask another pair of eyes to look at your solution. But anyway, read Terragrant config is very powerful way of including different things. So most likely the answer is yes, it is right. Okay, few samples I will show here. Okay, so this is one repository which I'm going to go through. This is another one, and this is third one. Well, this third one is not finished yet, but still. Question which I have actually received before this stream by someone. Actually by Sven Lita, I guess. So Sven asked if I can explore some of the AWS IAM multi-account examples you have put up. Yes, I don't have actually examples. Oh no, I have. Well, that's a problem. I have so many different projects laying around. I think this is it. No, not this. Reference. This one. Yeah, this one is. Okay, yeah, this one is related to the question by Sven. Talking about coding structure, and I will go through all of this and explain coding structure, how it, like what is actually the difference. Again, the main reference is gonna to be this meta repository where I contain meta configuration for all repositories, teams, files inside of Terraform AWS modules organization. I pointed to this repository a few times already during previous streams, and I think it is still relevant because here I use Terragrant in the public. Okay, so talking about structure, well, I don't know where to start from, but let's start from any place. Let's start from this one. Okay, this Terragrant reference architecture is the main place where I started putting information about, hey guys, this what is reference architecture the way I see it. I have been improving this repository over time and added a few things here and there and upgraded to different versions of tools. So it should be quite quite relevant right now. So what is interesting here is that here we have structure. We can see Acme master, prod, and staging. These folders, there is actually a description here below if you want to read. These folders contain information about each resources or infrastructure within these AWS accounts. So here I can say that my infrastructure is grouped by regions, by AWS accounts. There are some global stuff, some regional stuff. So this is one way of organizing infrastructure. This way is the most popular one, where because it has been presented or introduced back in the days by creators of Terragrant, and that's why it is usually taken as standard or as recommended by many people. The approach which is described in this solution is that you take your logical provider mental model, which in this case it is AWS, and we just understand how AWS resources are operating. So we understand that inside of AWS there is concept of region or AWS accounts, and then there are regions, and then there are services, and then there can be some environments. So we lay this as a folder structure to make it as similar as possible. I find this extremely useful for many reasons. Main reason here is that you as user don't have to think twice about what you're going to change. So you just, okay, of course I'm going to change application load balancer inside of EU Central, which is in production. Well, obviously you should go here and do some changes inside of this folder. So this is really important to understand, that your infrastructure is designed in a way that you don't have to think twice. So you only have to understand how AWS is structuring its own resources and what are the boundaries of these resources. So that's why there are folders like global, because you may know that IAM accounts or some roles, they are global for the whole account. The same for Route 53 zones, as well as what else? Well, you know AWS better than me, I guess. So the point here is that this is very good starting point, and you start with that one in many cases. The second step of code structure and how to look at this is that you may look into coding structure thinking about what is your working area. So working area is, I don't have any example, I think, laying around, but I can just explain that working area is another logical construct on top of let's say your cloud provider concept, where you group things together the way you work on them. For example, in your case, it can be one serverless function is actually a lot of different resources. So you may think about one serverless function contains of AWS Lambda resources, IAM groups, maybe a Lambda function permissions, and maybe a little bit more things related to this as a working unit. This is particularly useful for situations like serverless, because serverless resource itself is very seldomly used independently. You often use it in conjunction with API gateway or with CloudFront, so you may have them residing a little bit closer together. And the third pattern which I want to highlight here is related to this separation between service provider oriented, which I was talking earlier, versus application provider oriented. In application or application oriented approach, we have the basic thing is application specific like entities, where, let's say, when we're talking about making changes to application infrastructure, we are not thinking specifically about which services we are going to affect by doing this. We are talking about application from, let's say, application developer point of view. We are talking about this as a whole. This is very useful way of thinking if you have application with a lot of interconnected services. So then literally it looks like this. You have application and application infrastructure. And application infrastructure is actually a mass of all SQS, SNS, IAM, Lambdas, and so on. So all of this is like one big ball of mud. Sometimes if it is not very big, it is a rather efficient way of operating with it. But you have to be very careful because it will just it can destroy the point of infrastructure as code if you put too much things into one module and then your module suddenly become unmanageable. But yeah, just think about this. Service provider oriented is what I showed on this screen versus application oriented approach. Also, you may have different types of providers involved into one infrastructure. So then having service provider oriented approach is rather efficient to my mind, because you have separation on the very high level. For example, you may have folder called AWS and then another folder next to it called Rancher, another folder called Google, and so on. So this way you have very clear understanding of, okay, what do we have? We have this provider, this and this. Okay, let's dive into each of these specifically and let's figure out what's going on inside. So think about this as a way of organizing your code. On the example which I showed here, meta configuration, I'm talking about GitHub resources primarily. So here I have structure related for, let's say, main, where I have main configurations related to repositories, users, branches, and so on, which is not one resource, because it would be just wasting of kilobytes. But I just decide to work on this as main, as like all GitHub user role permissions and so on as a whole. And then there are a lot of smaller repositories where I take care of each individual repository as a separate entity. And I want to do changes, then I will do them in one of these. So that's one way of organizing it. Okay, now let's go into the next thing. The next one is, well, the list is pretty big. I don't know where to start even, but let me look into this code. Sorry, not this code. Yes, I should share it somewhere here. Cool. Now you should see this better. I will close something. So what I'm gonna to go in details, I'm gonna to show some of the features of Terragrant, and I will talk about code, how it is written and why it is written. I will pick a rather small example for this, not what many of you may expect, because if we just go into details of, let's say, multi-provider implementation, I will probably lose more than half of people who watch this right now, and I don't want to lose people. Again, let's increase complexity as we move along. And if you have something related to this specific section, please ask and we will go through this. Okay, so the first thing here is that AWS allows us to use different roles when we work with different pieces of infrastructure. Terragrant reference architecture, this is the place where I am right now. And here I have different folders. if I go to prod, then I see some infrastructure which is deployed in production. And if I go to any of this region, as I said, I have some configurations here. But how do I know which IAM permissions I should get when I'm modifying application load balancers here? Well, I may use different AWS credentials, and I may switch them myself and remember to switch them because, oh, now I'm going to production, so I need to assume a role in the production environment. Or, of course, I can do this automatically in some CI. It's not related. The point is that I need to do this. The way how I've been using this in the past, I don't do this so often nowadays. I don't know why, but in the past I've been using this quite often. Is that I used env.rc file where my tool, which is called dir.env, will assume it is an external tool which you have to install. I think using brew install dir.env. It will automatically look for files env.rc, and it will export this environment variable when I am working inside of this folder. So that's exactly what I want. So when I'm going to be applying changes into ALB, dir.env script will automatically tell Terragrant to use this role. That's pretty much it. There is nothing else what I have to do. The thing is that in order to assume this role, I have to have some IAM credentials installed somewhere. But these credentials can be set as usually using tools like AWS Vault or Vaulted, or I can put them into environment variables in any different ways. So once I have this env.rc here, and then I have env.rc here, you can see that it's commented, but it's using different account IDs, because master account is another account. You can limit this the way you want. You can limit the roles any way you want, and let your developers to assume this code or this role if they want. For example, all infrastructure is open in your organization and everyone can see it, but they can execute it only if they have permission to assume this role. So if they don't have permission, then they cannot do then they cannot run Terragrant here, and infrastructure will not be updated. Okay, this is easy thing. The next one is related to Terragrant hooks. In many situations, you want to do something before you run plan or before you run applies. Let me find inside of meter repository. I have which one is GitHub? This one, yes. So I'm gonna to set GitHub token environment variable every time when I'm gonna to call Terraform where var is supported. So for things like Terraform plan, Terraform apply, and so on, it will automatically run CLI before it will just set this environment variables by calling this run CMD. So it's not related to hooks as such, but sometimes, hooks. Where do I have hooks? Hooks. No, I don't have hooks here. Okay. Anyway, the point is that we want to be able to do something before apply. Here I'm not using hooks actually. I'm using features of Terragrant to run command, and it will run command called secret hub read. This is where token is stored, and it will make sure that Terragrant is quiet. So this secret is not actually output inside of std out, which is very important if you want to run something safer than usual. So this is one way of getting secrets or getting something before before you can use it. Talking about hooks, well, I kind of don't use hooks anymore, and the reason why I don't use it anymore is because there is a block called generate. Generate allows us to set information from this file into this path. So this file name is going to be _backend tf, and it will override that file if it already exists. So that's the right way of generating remote state configuration, and this remote state will now be stored inside of my repository. So if I go to main, here is file called backend tf. Well, actually, let me explain the way how Terragrant works. The way how it is supposed to be working. Okay, you have your infrastructure code written in any structure you want, and then you specify different files. Like Terragrant HCL is by default. You can tell Terragrant to use different files if you want, but by default it will just use Terragrant HCL. So the syntax of this file, actually it's easier to show on small example here. Here is Acme serverless, which I'm going to show now. Here we have, let's say, API gateway. Okay, yeah, that's a good example. So inside of API gateway, what I'm having right now, okay, we have block Terraform where we point to which Terraform module we want to use, and then we use block include to tell Terragrant to go upwards from this one and include first file, which is called Terragrant HCL here. So it goes from this folder to this one, and then inside of Acme serverless it finds Terragrant HCL, and what it does, it literally get the whole content of this one and combine it here. So it just put it here instead of this one, and merge existing blocks as well. So this is first way of don't repeat yourself. Okay, finding parent folders, that's a function which is built inside of Terragrant, and it does going upwards and applying this. And then we have a couple blocks, dependencies and dependency, which are not very much relevant right now. And we have inputs, which is just a list of arguments which this specific module accept. Okay, that's that's pretty much it. If you look into the list of these arguments, you can see that there are integrations and there are some references to dependency. Dependency.output.something. So this is where things are extremely useful, especially now. Well, they were, sorry, it's actually wrong what I said. They were extremely useful before Terraform 0.13 came out, and I will just explain it in more details. The thing is that what we have here on line 30, we specify that we want to use, we want to get this lambda function IRN, which is inside of outputs of this module lambda, which is actually a dependency, and this dependency is located inside of config path /lambda. So here we are. So this block contains reference to where the dependency is located. So here we have information. Okay, what I can do here, what I normally would do is that I can write IRN and then blah 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 and then figure out lambda ID. So first I need to go to that module, run this, or to that folder, run Terraform or Terragrant, and then put this value. What this dependency will do is that it will simply go to that folder and run Terraform output. Terraform output will output JSON, and Terragrant will simply take one of values which you reference here, and it will do this for you. So every time when you specify dependency and you are applying changes inside of this folder, Terragrant will go to that folder and it will run Terraform output, and it will put it here. if you have a lot of these dependencies, or even a lot of dependencies which are dependent on dependent on dependent, for example, it will take ages to resolve all of this. And literally it takes ages for some situations already if you structure your code in a very service-oriented way, where you have Lambda, and Lambda function may have dependency to Lambda layers, and Lambda layers may have dependency to something else. Then every time when you need to resolve Lambda function IRN, you need to call till the very end, which is just time consuming. This has been improved recently in Terragrant, where we can now say that we want to cache dependencies on certain level. This is great idea, but like for us, when we use Terragrant, we had a lot of challenges with it. So sometimes we were not able to get it up and running, but at the end, I think it works. So yeah, if you have a lot of interdependencies, make sure that you kind of optimize them. Another thing related to dependency is there is block called dependencies, and this is where you can specify that when you are applying changes into your API gateway level, you also need to apply changes into your other layers. For example, here can be layers which are not related to Lambda or to API gateway as such, but they may be related to some other tools or some other services which are not directly connected to API gateway. So you can specify a list of paths here, and Terragrant will apply those changes first, and then it will apply this one. It's easier if you try it, and then you will understand how things work. I will probably run it as well. Well, where exactly it is necessary? One thing here is inside of Lambda. Yes, inside of Lambda, what I want to do is that I want to also go to dependency, and I want to get allow triggers to make sure that I allow this Lambda function to be invoked from API gateway, which is specified here inside of this output. So I could run this one, but then you are soon discovering situation like circular dependency. So from one side, you want to apply changes to Lambda, which is dependent on API gateway. And when Terragrant will resolve API gateway, it will look and it will figure out that, oh, I actually depend on Lambda as well. So this is circular dependency, which is not so easy to solve in many cases. And for serverless, it is in particular challenging to solve, because there are a lot of resources just interconnected in very complicated way, but it's not related to Terragrant as such. So I will skip this for now. A few comments related to great parts of Terragrant. You may think that at least if you went to documentation and you saw, or maybe it's time to run something, right? I don't know. Is there anyone who's still watching? Let's see. Yes, there are 14 people watching. Good. So it means that we can continue. Okay. So yes. Good. Okay. Good. Okay. So let me just switch to terminal and show how things work, because now I'm going to talk about different Terragrant commands and what is actually happening there. Yes, if you have questions, you can write them, and maybe if it's related to exactly what I just showed, I will explain this. So feel free to write question. Okay, so here is the way. I have my code inside of, well, I can probably increase font size even. yes. Okay, I can increase it a little bit big. So what I wanted to show is that here is my infrastructure tree, where I have something inside of API gateway, something in Lambda, and I have another file which is parent, which is Terragrant HCL. Okay, so this Terragrant HCL, if I look into it, it contains similar information as I showed earlier. It contains block what to do with common variables, which I just comment out because there is no need for me to include something. But here is the same thing. Find in parent folders is used to find first existing files. This can be required or can be optional, and this is usually the place where I see a lot of creativity from people. You can include things recursively, conditionally, and be extremely flexible. Well, most of this flexibility means that you will not be able to understand what's going on very soon, or if you ask new people. I saw some very crazy things which were working, but not many people was able to understand where exactly this file was sourced. And there is a question already. In simple way, how do you debug any problems on Terragrant level? Simple answer, it might be just use Terragrant debug flag, but maybe there is something useful. No, there is nothing useful, honestly. And yeah, if you find information presented by Terragrant debug flag useful, then this is the best what you can get. Really, that's. I think this is just by historical reasons, honestly. It's not because of bad design or bad things or strange people developed this. It's just this how things were developed. When it was started in 2015-16, this project was developing so fast, and it brought a lot of useful features in first place. Then there were few, let's say half year maybe, when things were added not as useful, I would say. But still, debugging is historically hard to do inside of Terraform and inside of Terragrant as well. I have no clue if it will be simplified in the near future on any of these sites. Another question by Konstantin. If we have common variables, what is the difference between HCL, TFRs, and in our case we use YAML format file to store them? Answering first one is that if you use TFRs cannot contain anything dynamic. Okay, so you only have to put very static values there. So it all has to be resolved already. It means that your just one second. Where is? Yeah. So anyway, Terraform TFRs as well as all other TFRs, they're extremely static. If we are talking about including HCL, then inside of HCL files you can put any dynamic information as well. You can use read Terragrant, I think read Terragrant config function to read from any of these configuration files. It will read HCL and it will process HCL into native structures. So if you have read Terraform config function to read from let's say a.hcl, then this will be mapped into native list maps and so on, so you can reference to them by key, so you can then get them. In Terragrant example, they use regional HCL. Yeah, exactly. So they can use anything related to HCL and include it using read Terragrant HCL. And that's that's very good pattern. I think it is highly recommended to split your configuration files and put them in places where they belong. If you have regional.hcl or .tfrs or .yaml, it doesn't matter. But what's important is that it is stored in a place where you define your region configuration. So if I look into acme prod EU central, I have regional TFRs here. And again, it doesn't matter if it is TFRs. TFRs here is just by historical reasons, because it was not possible to read Terragrant config files before. But anyway, information inside of regional is very static. It contains just which region we are, nothing else. Okay, so right, so where I was, yeah, and you can also see dir-env is suddenly working. So dir-env automatically loaded env.rc file, and it exported Terragrant IAM role because I was switching to prod account. So this means that if I would run Terragrant apply there, then it would use this IAM role which I instructed it to have. And again, if my user wouldn't have permission to assume that role, that's another problem. Then I'm a bad guy who was not allowed to do this. So that's good. Okay, if we look into serverless again here, what I have here, essentially two folders, API Gateway and Lambda. If I go to API Gateway, and then what I do here is that I can run Terragrant init, and what's going on here? Well, I have good news and bad news for you guys. So the bad news here is that it worked, and you may think that, oh my god, that's a lot of output, and where to even look, like what's going on here. Well, yes, this is a lot of output, but this has nothing to do with real output. User local bin. This is even more output, right? So you can see that this is even more output. The way how this can be done, like if you compare this output, it's a lot, but still can be simplified. And this. So what's going on here? This is a function which I use because I don't want to see a lot of things. So I cut everything what is Terragrant, timestamps, pass. I simplify because I don't want to see this prefix all the time. So here is this function. If you want to see a little bit less from Terragrant, this is function for you. Yeah, you can go to, like, I think, yeah, just one second, I will find it. We love output, yes, when it is self-explanatory. Well, I don't think the output is easier in many tools written in Go. I don't know why, but I felt this many times. Okay, let's see. Yes, here is this function. I will put this link into chat right now. Maybe it's okay. Yes, cool. Okay, so this was about output. There is a lot of output. You can make it less, but not so significantly, I would say. So what I did right now is that I run Terragrant init, and it just verified which version I'm using, and it downloaded dependencies. In this case, it was this module it downloaded it. Cool. Then it generated some files which I instructed it to generate. The way how it is how it works is it Terragrant HCL. So here is a configuration file which is in the parent directory. We have this block called generate, which was added approximately, well, less than a year ago at least, where we can specify what kind of files do we want to add by Terragrant. So in this case, I'm adding content of provider section, and I save it inside of main providers.tf. Same I do for remote state, which is stored inside of backend TF. One of the convention which I think at least I thought I'm following, is that if this file was generated, I started with underscore. Same as if this file is private, I like to start it with underscore. So that's why this backend is starting with underscore. I don't know why I didn't put underscore here, but I think I should. The point is that the way how it works, let me explain one more time. We have this structure. Here we specify, yes. So here we specify that to spin up API gateway, we have this configuration file. What Terragrant is doing is that it's downloading a module and it's putting content inside of this strange folder. So this folder now contains all source code of the module itself. So this is exactly the point of Terragrant. Terragrant allows us to not think about individual files or modules or somehow invoking this, or even more complicated is that it does not let us or doesn't ask us to think about outputs TF and variables TF. So these usually files where we have declaration of variables and outputs blocks. All we want to do is that we say, hey, Terragrant, please get source code from this module folder or from this module and pass different variables to it. What it means for us is that Terragrant creates this temporary folder where it will call Terraform. So one way of debugging it is actually run Terragrant, and then if you don't know what's going on, or Terragrant may be a little bit too slow for you right now, then you simply go to this folder and then you run Terraform and apply, for example. And if you run Terraform apply here and you make sure that you have correct credentials, you will look or you will be doing very similar things as Terragrant would be doing. With only exception is that Terragrant understand how to get information from input blocks from this one, and how to pass this information into variables into Terraform, and it will do this for you transparently. So you don't see this in outputs, you don't see any files generated for you. So this is a little bit tricky by default. I think the command which Dominic mentioned, Terragrant Debug, or we can specify here, I guess, if we go here, 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 and if we run debug, no, sorry, no, I don't have this in cache. So, but if we run Terragrant apply Terragrant Debug, I guess this is it. Then Terragrant will now generate a file, and it will tell you what's going to do. Run this. It says run this command to replicate how Terraform was invoked. So it actually generated this TFR JSON file, and it put something there. So this is pretty good way of using Terragrant for parts where you want it to be, but then use some other tools to actually run Terraform, which is very seldom when you need, to be honest, but still it is possible. Is it possible to pipe some script output as an input for Terragrant? No, you need to create files physically. It does not accept. No, I don't think it accepts any std-in content. So no, probably not. What you can do is that now if you run Terragrant and I run Terragrant apply, it says that nothing has been created because I have already created it. What I can do is that I can see a lot of outputs here, right? So what I can do is that I can run Terragrant Output, and then again I should wait a lot of time. It runs a lot of magic, and then it shows me a lot of this output. That's pretty much useless to do in automation. So if I now say, okay, I want to use this one, and again, it's outputting a lot of things for you here, which doesn't make sense for you, and the last line is the one which you cared about. So as you can see, there is no easy way to skip all of this output. The only solution which I know about is that you have to pipe it into file, and you have to put it, let's say, what is it, output.txt. So what's happening right now is actually useful. Well, it takes some time, but now we look into output, and it doesn't work. Oh yeah, right. That's because of my script, which is local bin. So now we have all of this output printed here, like this is how it was working and all of this, and then there is no real output which we wanted because it is already inside a file. So when you use Terragrant without wrapper, then it works as expected. So yeah, this is one way how you can do this. But what I want to talk specifically is about one of the most beneficial feature of Terragrant, and I've been using it quite a long time until I figured out that I was using it for bad reasons, I would say. So this feature is called apply all and plan all and validate all. Let's look into how it works. Okay, I go to Terragrant and I'm gonna to run apply all. Let's start with this command. So what it says is that it's gonna to execute all dependencies because it figured out that API gateway depend on Lambda, and this dependency is outside of my current working directory. So do I want to say, and this is still, every time when I see this one, I'm confused. Like if you run Terraform apply, you have to type yes only. It doesn't accept anything else. But here it says, warning, if you say yes, Terragrant will make changes in Lambda as well. And then yes or no. So yes or no or yes. Well, I don't know what to type. I think I type yes every time. So yes, I want to apply these changes. Then it figures out that there are these dependencies. API gateway depend on Lambda, and Lambda does not depend on anything. That's pretty much it. Yes, go and apply Terragrant apply in all of this. So now it's doing the magic. It's going around and executing Terraform apply. As you can see here, Terraform apply in all other folders. And that's pretty much what I want. It executed changes inside of Lambda function. There was nothing changed. But even if there would be anything changed, and let's say there would be new Lambda function I ran produced, then this change would happen before API gateway need this value. So if you remember Terraform before 0.13, where we didn't have depends on between modules, this was extremely painful to remember the sequence of commands to execute and what has to be created first and second, and the countless workarounds. So that's exactly when Terragrant was shining. Terragrant simply take these dependencies outside of your code. So here we have execution of another layer, which is API gateway. There is nothing changed here, and then we see that everything is okay, has finished successfully. That's pretty much flow how I want it to be. Okay, now let's look into two other commands. Another command which is called plan. As you may see, I'm talking about Terragrant quite positively now. I'm not stumbling on any errors, or I'm not seeing anything what is far from logic. So far, so good, I think. Until I run Terragrant plan all. Traditional question, this time let's type yes. It still works. Well, it works, but it even skip asking another time. Anyway, so I said yes because I want to run plan in all of these folders and I want to see how things are going. And then I see some plan. And then I see some other things, and then I see API gateway applied, and now I'm sitting and thinking like, hey, so how useful was this information? And the answer is no useful. Like absolutely no, there is no useful thing in this information for me. And this is because if I have a large amount of resources dependent, then this is just text floating around, I have no clue where things are actually coming from or how things are actually related. Like, honestly, I have no clue which layer this code is actually affiliated with. Like in my case, I deliberately select very small example, API gateway and Lambda. But if I would have 20 Lambda functions and 5 API gateways, plan all is absolutely useless thing to do. Additionally to this, where plan all is having very hard time, is in resolving dependencies which are not yet known. Because imagine the situation: you didn't create any infrastructure, or actually let's destroy it, right? I mean, Terragrant destroy all also exists. It's something what I don't think I run so often, but okay. So if I run, let's destroy everything what I just created. And let's see how things go. So first it goes to delete Lambda function. I guess, no, it's deleting API gateway, of course. It's getting output from Lambda function, but then it's deleting API gateway because it has dependencies. So cool, it will delete API gateway, it's gone. And now Lambda function is deleting itself. So everything is fine. And now look at this from a new user perspective. You go to this project, you go to, let's say you go to, you go to API gateway. This is a easy place. And you want to say, hey, let's plan all of this, okay? We can run plan or we can run plan all. For this specific example, it's not big difference. The difference is that if you run plan all, it will also look in all dependencies which are specified as dependency. So if you have large list of dependencies, then it will also make sure to plan those too. But if you use just plan, it will only plan things which are related to this one. So since I'm talking about plan all, I'm going to say that yes, I want to plan all things inside of my Lambda function, or inside of API gateway, sorry. Cool, I run something, it tells me that, hey, now Lambda function will be created. I'm really excited. And then it says like, hey, dependency Lambda just finished successfully, and everything is going to be all right. But then it fails because there is dependency on an object which has not been yet created. And that's actually true, because code inside of my inside of here, so this is API gateway, is pointing to lambda output, and I don't know yet this lambda function I ran. We may go to different workarounds here, which will end up in writing another map here in dependency to mock a response from that section. This is last thing which I want to do if I'm working with infrastructure as code. Honestly, mocking something in order to see plan, no, not really. So yeah, plan all is not useful so much, primarily for this reason, is that it just tries to do happy pass and then it fails in most cases. So plan all is highly not recommended by anyone, including developers. So the last command, which is related to validate all, as you may assume, it does similar behavior, but validate all at least going to work now in Lambda, and then again it doesn't work inside of API gateway because there is no output and everything fall apart. Well, to make this thing work, I need to write a lot of code somewhere inside of Terragrant HCL, in particular around these lines. I don't want to do this, and I was told that it's about dryness, it's about simplicity. If I'm going to do this here, it's far from simplicity. Okay, so this was pretty much like things related to bad things in plan all and validate all. So the only command which makes sense to be used here is actually apply all, and I need to make very important note or comment that you don't want to run apply all so forcefully without clear understanding of what exactly is going to happen, right? You always want to see plan and then make sure that, okay, yes, it looks good, now apply this one. If I run, let's say, if I now run apply all, and again I was asked, I said yes, I'm crazy because I want to apply my API gateway and Lambda function, and it's doing this. So what's going to happen right now is that I have no control of what's going to happen. I don't see my plan. There is no way for me to interact with it and say this should be applied, but this layer should be skipped. Nothing. So the only situation when apply all is safe to run is when you have absolutely nothing to lose, which is usually like, hey, disaster recovery, we have absolutely nothing to lose, please spin up whatever you can. Then you can go to this folder and run apply all. Anyway, your fingers are crossed already that things will work, and here you are. Another situation when I use apply all is when I spin up my infrastructure in parallel environment, which is similar to disaster recovery process in terms of I have nothing to lose and I have nothing yet created anyway. So I'm going to, let's say, spin up infrastructure from previous release and it works somehow, it does what I want. And then I'm going to pull latest version which I want to put there, and I'm going to blindly run Terragrant apply all again. And since it is running on isolated environment, which is not affecting any user or any other system, it's pretty good. So then I have more guarantee that this specific configuration will succeed inside of other environments. So I think it is like it's great by design. Honestly, I was believing into these functions for a very long time, and plan all was like, yeah, it looks good, but in theory, in reality, that's not going to work. Validate all is even better, but still not so good. So apply all is the only command which works. but it's rather risky to run it on production if you run it so often. Okay, well, we are actually 1 hour, so we are already for 2 hours. Oh my god. Let's see, I have a few other things, small things, and then I see I will take patterns and actually complaints and limitations and challenges on second part, because now it just takes too long time. So talking about Atlantis and other interesting tools which can be used. So Atlantis support, for those who don't know what is Atlantis is this one, Terraform pull request automation. Well, it works natively with Terragrant as well. For me, honestly, it took a lot of time, a lot of efforts to figure out how to get it up and running, and then I just gave up. Because, I mean, it works, but, well, I didn't have a real project where I can put this in action. So, it works, but required some magic long time ago. Now it is well documented, and there are a lot of people using it with Terragrant as well. So Terragrant config. No, what is it? One second, I forgot the name of the project, which is related to Terragrant. I use it in another repository. Here is it. I remember the name of the company. So, what is this one? This one is actually generating Atlantis configs for Terragrant projects. I think it is really cool things. Right, yes, I'm still presenting. Oh my god. Right, so you didn't see, guys, what I was talking about. I talked about this Atlantis, which is cool, but required some like a workaround. And now I'm talking about Terragrant Atlantis config. This project allows us to specify. You are presenting not browser. Well, no, I present my browser right now. Okay. Yeah, so this thing allows us to generate YAML config, which is required for Atlantis, where it will understand how your Terragrant project is structured. I think it is pretty cool in terms of goal. When I was trying to use it with my real Terragrant project and Atlantis, I used to modify final YAML file still a little bit because it didn't include some details, and I know that few people have been in the same position. But anyway, it is a great start, and the end result will be that once you run this command, it will have this YAML file, and it will also respect a lot of internals of Terragrant, like it will understand different dependencies or where things change. It will also update them in another place and so on. So I encourage you to check out this documentation and the project itself. I think it is very much useful. Okay, question by Konstantin. How in this case to manage the whole infra to make it consistent and make sure that you don't have any discrepancy? Well, what I can do here is that yeah, I guess the question is related to this one. So yes, I said a little bit too much about Terragrant working badly with plan all and validate all, but apply all still works. So the way how we can do this is that we can still run plan all, but if it fails, it doesn't mean anything. Only if it succeeds, it gives us kind of information that we have a lot of dependencies. Yes. So what I think is kind of very important to understand is that when you have infrastructure organized by environment, by reusable modules, then you have to make sure that you spin up your infrastructure in parallel stack on your test environment, and you verify it and you think it's okay. Then you can apply it to production environment. But there is no easy way to run apply all and everything will be magically work on your production environment. This is really a like big misunderstanding, I would say. I see. Okay, let's one. This is. I see a lot of cases in my company when something was changed and wasn't applied, or was applied from people's branch and was written by the what is it? Overwritten by the run from master branch. Well, this is typical people problem. If you don't want people to run this infrastructure from their branch, then introduce any CI system. Let that CI system to run this code for you, and whatever they create from their branch should be overwritten from single source of truth, which is master branch. There is no no easy solution to people. So I think it is actually quite easy to solve. You simply revoke access from these people from environments where you don't want anything to be applied, but give them full flexibility to do whatever they want on limited environments. So they have fun and apply whatever they want on dev environment or their personal environment. But then, as soon as you want this to be streamlined, you actually enforce this to be applied on some sort of pipeline, on test, on staging, on production. Otherwise, there is no way to do this. Atlantis can certainly help with that. As Max just said, is that it can work on auto merge. There is auto merge and something else. There is auto merge. Well, there is another auto plan. Yeah, there is a feature called auto plan, which will automatically invoke Terragrant plan when something has changed in dependencies. Or it can also merge pull requests once they were applied, or something like that. I'm not a big fan or big kind of expert in this flow, to be honest, because I still have like debatable position most of the times. From one side, I want master to contain all information, and this information should be real, but at the same time there can be a lot of last minute pull requests because you didn't have enough certainty and you applied this code a little bit wrong before. So then you apply a lot of small patches to it to make sure that it's actually working as expected. But in most cases you will have very good control if you simply put all of your infrastructure in code and you let your developers to just run this like from master branch. So they can do whatever they want from their feature branch if you use this, but everything what you want to control, sorry, but you cannot run yourself. So Max also said once one person did the plan, others are locked from planning and applying. Yeah, so this is typical feature of Atlantis, really. Well, I can probably put this somewhere here. No, here. Yeah, okay, cool. Okay, next thing is going to be, yeah, so Atlantis is one way of executing Terragrant. I definitely want to go to complaints, limitations, and challenges, but I will do this next time. So next time will be even more pessimistic edition of Terragrant review. But one thing related to today's session is that pretty much I don't know any CI system right now who are taking Terragrant seriously. It's a little bit crazy. So, and every time when I talk to these companies and ask them like, well, thank you very much for support of Terraform, you are company number 25 who say that Terraform is crazy and definitely important for them, but what about support for Terragrant? And none of these companies say like, oh yeah, we are aware that let's say Terragrant, well, where is it? Terragrant issues. Well, issues is for tomorrow or for next time. So they say like, oh yeah, we know that this project is used, but 4,300 stars on GitHub doesn't mean enough to us, so we are not gonna to make Terragrant supported in our awesome CI system. And what people have to do is that they have to run Atlantis or their own system, which they maintain themselves, which is a little bit strange, I would say, but I kind of understand them as well. Okay, do we have any other questions? Oh yeah, I forgot to highlight comment by Sergey Vasilenko. So yes, Sergey was so naive thinking Terragrant is just a framework, nothing complicated. Well, if you want to use Terraform framework, you can do this. There are, if you go to Google and write Terraform framework, you will see find like TerraSpace, which has started recently by Bolt. Yeah, so this guy is actually developing pretty interesting things. Well, not so interesting. Zero forks. Well, I don't know why there is zero forks. Maybe people didn't understand how to write Ruby. But anyway, this is a real Terraform framework. And there are a few other solutions to that. Terragrant started not as a framework. Terragrant was supposed to help us with removing boilerplate code, which typically variables, outputs, remote states, passing variable and var files in different ways and so on. And I think it is succeeding quite okay there. But amount of other extra features which you can read in documentation, well, I'm just crazy. I'm sharing one screen and talking to you guys. So yeah, TerraSpace was framework. Okay, so I think it's time for wrap up now. Let me share another link to Zoom. So I think it's gonna to be cool if we go there and if we keep unofficial. I really think that we can go there and continue there. Well, thanks Sergey for support. Well, yeah, I hope you didn't mean expiring, but inspiring, because expiring means that I will have to change my stream when we have Terraform 0.14 out. Well, I don't mind to go there. Auto correction, yeah. Okay, so let's see. Yeah, let's join this Zoom and we continue there. Yeah, and the very last thing which I want to say is that this stream sponsor was N0, which I have somewhere here. Self-service cloud environments. So give it a try and see what you guys think about it. Because I know that a lot of people suddenly decided to worry about one more thing, which is cost. It's crazy. So many companies now say like cost is what we worried about. So here we go, guys. You can see how much your stuff actually cost. Okay. I don't think there are other questions right now in the YouTube. If there are any, please write them somewhere here. Links I will put in description. And That's it. See you in Zoom.